Alrighty, so in this video, we will be looking at graphing quadratics in vertex form. We have been dealing with quadratics in standard form for the last several videos, or for the last several lessons, which remember was y equals ax squared plus bx plus c. We had an a, b, and a c. And if you'll notice in vertex form, we've got an a value, an h value, and a k value. The a value works the same exact way that the a value did in standard form. However, this is called vertex form because our vertex is given to us, the coordinates of the vertex are h comma k. Now the h term is what follows the subtraction sign, and the k term is what's at the very end. All right, so let's see, what does this look like? We've got y equals -3. We got this quadratic right here. So the first thing I want to do is I want to figure out what's my a, what's my h, and what's my k. So the a value is -3. The h value is the number that follows the subtraction sign. So you see it's x minus 1. So all I'm going to take is the 1. Okay? And then the k value at the end is +4. So the k value is 4. So my vertex can automatically give that as hk. So 1 comma 4. So in this table, I'm going to put 1, 4 there. That's my vertex. And I'm going to graph that over here. All right, axis of symmetry is next, and that should be really quick. Because remember, the axis of symmetry is just the x-coordinate of your vertex. So whereas in standard form, we found the axis of symmetry first, doing -b/2a, and then plug that back in to get our vertex, this works a little bit differently because we can find our vertex first and then find our axis of symmetry quickly after that. So I'm going to draw in this vertical line, this symmetrical line that's going to cut my parabola in half. All right, now let's finish out graphing this parabola. So we need to plug in a couple more points. So I'm going to plug in 2 and 3 because those are above 1. I'm going to plug in 0 and -1, which are below 1. Okay, so if I plug in 0, so that's, if you remember, if I plug in 0, that's going to be the same as my y-intercept. If I plug in 0 for x. So y equals -3, plug in 0 for x, -1 squared plus 4. As I simplify this using order of operations, you're going to see that when I plug in 0, I get out 1. Okay? So that is my y-intercept. It's not as easy as the y-intercept of standard form where it was just the c term. Okay? But here, all you got to do is plug in 0 and see what you get out. So I get out 0, 1. That's the coordinate. Because of symmetry, if I plug in 2, I'm also going to get out 1. Now let's plug in 3. So I'll see y equals -3. Every time I see an x, I'm going to plug in 3. Okay, now if I simplify this, I'm going to have -3 times 2 squared plus 4. Well, 2 squared is 4. So -3 times 4 plus 4. -12 plus 4. So that's going to give me -8. So if I plug in 3, I'm going to get out -8. Similarly with symmetry, if I plug in -1, I'm going to get out -8. So to finish this out, I'm just going to connect the dots. A nice smooth curve. I got a little wonky on the left side, but that's okay. All right, going through those 5 points. Okay. Now for transformations, that's going to work the same way it did for standard form. So remember, transformations, that's like reflection, vertical shift, all that stuff. So the a value tells me whether I have a reflection and whether I have a vertical shrink, a vertical compression, or neither. So the a value is -3. So because it's negative, I know I have a reflection. So because the a is negative, that's how I know I have a reflection. The a value is -3, which means it's getting stretched in the negative direction. right? Because just think, if it's Play-Doh and I'm trying to make it 3 times the size, I have to stretch it out. So this is a vertical stretch. Oh, be helpful if I could spell. Vertical stretch. Okay. Now for a horizontal and a vertical shift, we need to look at our vertex. If you'll notice, our vertex changed from 0, 0 to 1, 4. So for the vertex, for a horizontal shift, it went to the right 1. And for the vertical shift, it went up 4. Okay, so those are the transformations that are going on here. Now we need to look at the x-intercepts. And to do x-intercepts, we need to figure out how to use our graphing calculator. So I'm going to hit y equals, I'm going to plug in the function just like you see it, -3, parentheses, x minus 1, parentheses, squared, plus 4. After I have that typed in, I'm going to hit the graph button, graph my quadratic. Now, I'm going to use the x-intercept button. So I'm going to use second trace down to 0. And this is when we have our left bound, right bound guess. So the left bound of our first x-intercept, you'll notice the left one, a point that's to the left of it, we'll say -2. That's to the left of it. To the right of it, I'm going to say 1. And then for guess, I'm just going to hit enter again. And you'll see that the first x-intercept is -0.1550. Now for the next x-intercept, I hit second trace, go down to 0 again. Left bound for my second x-intercept, I'm going to say 1 because 1 is to the left of the second x-intercept. To the right, I'm going to say 4 because 4 is to the right of that point. For guess, I'm just going to hit enter again. And you'll see that the second x-intercept is 2.1550. Okay, so that's how you graph in Vertex form. Okay, if you have any questions, just email me. Let me know while you guys are out. If you have any questions, I'll be available from 9 to 2. In the next video, we will talk about how to solve a word problem that's in Vertex form, and then you'll get to practicing. All right, let me know if you have any questions.